I've been moving my servers to a brand new rack.
Is it a nice rack?
Oh, it's a lovely rack.
Is it a full height rack or a half height rack?
It is am I going to get this right? I think it's a 12U rack.
Aha. I can't remember how many U there is in a rack, actually.
42 is a full one, isn't it?
It is. I think you're right.
Yes. So this is, I guess it could be freestanding, but it's like a cabinet which I've mounted up on the wall in my garage.
Very nice.
So previously, up until about 4 or 5 months ago, my microserver lived in essentially a cupboard at the back of my garage, which I drilled some holes in to route cables in and out of. But it was just sort of like a kitchen cabinet that the previous owner had stuck up on the wall to keep his tools in and stuff. It wasn't terribly practical because it wasn't deep enough to sit the server in face on. So I actually had to have it sort of shuffled around the side. But it sort of worked, and it was preferable to having it in the house because the places I could have it in the house get very hot in the summer, whereas the garage stays nice and cool because it's north facing and doesn't get any direct sunlight really. So it's a nice environment for the server to live in. However, in my recent renovations, the wall that cupboard was attached to got knocked down.
Intentionally or otherwise?
Oh no, very much intentionally.
Okay.
Because that part of the garage is now part of my kitchen. And I didn't think it would fly keeping my servers in one of the kitchen cupboards, really.
Yeah.
That would not have met with family approval.
Especially not with visitors.
Yeah.
Yes.
Where are the cups? They're in the cupboard next to the server. Okay.
Boo. As the server gets hit on the way in.
Yeah. I kept it all up in my office for a while, sitting on the floor. But when all the building work was finally done, I thought I'm going to do it properly this time. So I managed to find a seller on eBay that did flat-packed server cabinets for a reasonable price for the size and put it all together. None of my stuff is really actually rack mountable. So what I ended up doing was buying some shelves that mount on the rack and then just sitting everything on those. What I have done is get a rack mountable patch panel for network cables because I have wired network between all of the rooms in my house. At the moment, there is only one cable going down to the garage. So while I have 24 network sockets at the top of the server rack, I do only actually have one connected, although my grand plan is that I will route all of the others so everything terminates at the server rack eventually.
And how many cables will be terminating there? How many rooms have you got wires going to?
So I think there'll be 6 in total.
So quite modest then.
Yeah, I'm running a 3-bedroom house. I'm not running a multi-thousand person company here.
Yes, it's your Kubernetes cluster in the bathroom.
Yeah, it's water cooled.
Right.
I've got an 8-port switch sitting on one of the shelves in the rack. Plus, I've got my cable hub router modem device from my ISP in there, which has 4 ports on it. So I think between those two, they'll be able to serve everything in the rack and all the connections up to the rooms between them. So that's about the scale of this endeavor.
Okay. So you've mentioned the 2 bits of networking equipment that's in your wall-mounted rack. What computers are in there?
So I have now my microserver, which has pride of place in the middle, taking up most of the space. And nestled next to it is my Wise thin client server, which is the always-on server. So my microserver sits there asleep most of the time until the Wise summons it via Wake on LAN into action.
I should really do this. I have 2 microservers that are currently active. Although, actually, no, one of them's turned off. So I've only got one active, and it's on the desk behind me right now, and I have to turn it off every time we record a podcast and then turn it back on again, and then SSH in and start a Docker instance. I'll figure that out at some point. Is it quite normal to put, like, non-rack mountable stuff in a rack? Or is it's just a convenience thing because you can close it and lock it, and it's a piece of kit that you could turn into rack mountable stuff over time? Is that the intention?
Not necessarily. It's really just a nice way of organizing it and having it all contained and in a nicely ventilated box rather than just sitting out in the open on a shelf. And there's space behind the shelves to route cables up and down and so on. So it's just a practical way of doing it, really.
I've been writing so much Python, I forget which thing I wrote this week, so I had to make some notes. We had a situation at work where one of the developers had done a pull request against one of our open source tools, Syft. And the intention of the pull request was to improve performance. And we wanted some data to prove that it really improved performance.
Always a good idea.
Yeah. And a couple of us just ran the code and tested it a couple of times, but I felt like that wasn't enough. I felt like it needed testing multiple times and then get an average of how long, because it's non-deterministic. There's like other adverse things that can cause it to take longer and shorter periods, like caching and the load on the system at the time. So I thought if I run it a few times, I didn't want to do that manually. Who does that, right? So I decided to write a thing, and it's called Measure Syft because it's intentionally to measure Syft performance. And then, as Martin has pointed out before, scope creep entered the game. So the reason the scope creep happened,
Officer.
yes, I can legitimately give a reason for this. The reason the scope creep happened is because I tested the latest stable release of Syft against the pull request and said, here's the difference between the two. And that's unfair because there are other things that landed in main that were also in the pull request that was about to land in main. And so I wasn't really testing that pull request. I was testing that pull request plus everything that's landed since the last release, which was unfair. So I thought, well, what I really should do is test main against the new pull request. Like, what's at the tip of Git and this new pull request? So I wrote the script to do that. And I also thought, well, while I'm here, I might as well give it an option to pull the latest release and test every commit that's happened since then. So then I could see if we have adversely caused it to get slower with one commit or luckily caused it to get faster with a commit.
Am I right in remembering that Syft is written in Go?
Correct.
So this actually has to pull the code for each version you're testing and do a build and then run the benchmark command that you're using.
Exactly. That's what I was doing.
Right.
The start of the script goes and finds the latest release. It just looks at the GitHub releases, finds the latest release. That tag is where it starts from, and then it goes forwards from there. So it starts by getting the latest release, builds that, tests it, then moves forward one commit at a time until it gets to the end. And we don't generally have a huge number of commits from one release to the next. And a lot of them are things like dependable, like updates to dependencies, but that still could impact performance. And so I thought this would be a useful thing to do. And sure enough, I made it produce a report at the end where it lists all the pull requests in markdown format. And it shows the minimum time, the maximum time, and the average time for each of those pull requests when pointed to any given container. And to really stress Syft, you really have to use a complicated container because some of the copiles won't be executed. Like if you point it at a Red Hat container, it's not going to look at debs. And if you point it at something that's got no Java packages in it, then that doesn't exercise that part. So we kind of really need a monster container that's got all manner of nonsense in it to exercise all the code paths and to standardize on that and use that container. I haven't got to that bit yet, but I probably will have an awful container that's got debs and APKs and RPMs and Java packages, Python packages, Rust packages. Like I'm just going to jam it all in there and then have it test that. That's probably where I'm going to go. But for the moment, it just creates a summary table of whatever container you point it at, and you can make it run as many times as you like. When I ran this against all the commits since the latest release, there were 29 commits, and it took 12 hours to run on my server in Germany. And I was running it with this parallelization option on. So it was running with 2 times the number of CPUs as threads. So it's got 12 cores. So it ran with 24 threads because one of the features that we were testing was how good is the parallelization of like splitting the load across a bunch of processes rather than just having a single thread. And yeah, the new pull request is great and it really does improve performance quite dramatically, like 10% faster on pretty much every test I did, which is double digit, which is a good improvement by any stretch of the imagination. It hasn't landed yet, but it will. And we might even get other gains further down the line with what we've learned from this one. But I just found this whole, I'm a number nerd and I love charts and I love markdown tables. So like put the two together and what do I get?
Are you familiar with Git bisect?
Yes. That's where you've got, 2 points and you want to try and find the place where something got worse or better or something, right?
Exactly. So that might be a useful tool here. If you have a bunch of commits, you don't want to have to run every commit. You could have it work out, oh, was this commit better or worse than before, and then narrow down the number it's got to test in between. So you wouldn't necessarily have to run for the whole 12 hours.
Yeah, that's a very good point. And I wasn't actually aiming to find a particular, it wasn't like I had a problem that I was aiming for. I was just testing this script out to make sure it worked. But it was good fun. And one other thing I had to factor in, and I'm glad I did before one of the developers asked me, was you point Syft at a container, and that container comes from a registry like Docker Hub.
Yeah.
And I was pulling this 10 gig container, but we wanted to make sure that it was cached on the local machine. And so before I did the loop, the timing loop, I pulled it without timing it to make sure it was on the machine, then started the timing loop, because chances are it wouldn't be kicked out of the cache because there's nothing else going on. And that seemed to help. And running it, I think I ran it 5 times. So it's 29 commits times 5 times. It was good fun. And I put it on GitHub, and I'll link to it because, why not? And it's just a little bit more in my little journey of Python nonsense.
This sounds like a useful tool to bake into your CI/CD. So on each pull request, it actually does a test to see, has something gone horribly wrong here, or is everything fine?
Yeah, that's a good point. And we did briefly talk about that. I'm not sure whether it's robust enough for that at the moment, but a derivative of this could certainly do that. I mean, I could just have it watch the Git repo and run it on my infrastructure because it, like I say, it takes a while, but you don't need to run it on every commit repeatedly. All I need to do is compare it to the tip of Git and the last release. I think it's good to compare to the last release because you're getting end user feedback there. Like I was using 1.19 and 1.20 got slower, or this commit makes the thing run faster or slower compared to the previous commit. So all those kind of like analysis. And I know lots of people have probably got professional tools that do all of this kind of stuff, but I was just interested in figuring out how to do it myself. And it wasn't that hard. And had a nice markdown table at the end of it with all clickable links to all the pull requests. So you could see where all the code came from and who's to blame if it was slower. But thankfully nothing was dramatically slower. They were all within a margin. Oh, that's another thing I could put. Like a deviation from, oh gosh. I should file an issue for this. Oh man, it's never ending, is it? This episode is sponsored by Tailscale, but please don't skip. I want to tell you how I use Tailscale's free plan to securely share remote access to web applications I'm prototyping on my laptop. Sometimes I want to test those web applications from other platforms, such as mobile devices. With the Tailscale serve command, I can share a link to my creations on any other device on my Tailnet. I have Tailscale installed on all my devices, so I can access my prototype app from any device securely and without fuss. And if I want to share my creation with friends, colleagues, and customers, I can use the Tailscale funnel command, which gives my application a public URL for as long as I need until I close the funnel. It made authenticating my app with GitHub easy because I could use the public Tailscale link as the callback URL. No need for router port forwarding, and SSL is automatically enabled by default. Both Tailscale Serve and Tailscale Funnel are handy for developers like me. Many of the late-night Linux family hosts are using Tailscale on their devices to secure cross-device networking, and you could too because Tailscale's personal plan will always be free. To support the show and become a web developer like me, try Tailscale for free today. You'll get up to 100 devices and 3 users for free with no credit card required at tailscale.com/Linux Matters. That's tailscale.com/Linux Matters.
Linux Matters is part of the Late Night Linux family. If you enjoy this show, then please consider supporting us and the rest of the Late Night Linux team using the PayPal or Patreon links you can find at linuxmatters.sh/support. For $5 a month on Patreon, you can enjoy an ad-free feed of our show. Or, for $10, get access to all the Late Night Linux shows ad-free. We love to get your feedback via email, show@linuxmatters.sh, or you can chat with us and other listeners in our Telegram group. All the details are available at linuxmatters.sh/contact. I am writing a video game, so naturally I started by not writing a video game. I have written something else entirely.
That's the spirit.
This came about because the last time I entered a game jam, I used Pico 8. And in so doing, discovered Lua as a language, and I decided Lua is pretty great for the scripting language on game engines. So ever since, I've been tinkering with game engines that favour Lua as sort of the binding language. And Default is one of them, and Solar 2D is another. But I've actually decided to write the game I'm working on using Love 2D, which is a very fun and quite minimal. It's not a game engine, it is a game framework. And if you're unfamiliar with Love 2D, you may be familiar with the indie game of 2024, which was written in Love 2D, which is Balatro.
Balatro is like a card-based RPG thing, isn't it?
Yes.
I've not played it. I've seen videos of people playing it, that's it.
It's a roguelike poker game, I believe.
Yes, ring the bell.
But written by someone who I don't think ever actually played poker himself. He just thought it would be a good framework for a game that he could then mess around with and do cool stuff.
Wonderful.
Yeah, he was writing this game for sort of 6 of his friends, and it's become fantastically popular.
So what have you written that's not the game then?
So going back to Pico 8, one of the things I struggled with when I was in the pressure of a game jam was suddenly you've got to get your game out and published and all the rest of it. And this actually burns a whole bunch of time. And in addition to using Love 2D to create the game I'm working on, I also want to participate in some game jams over the course of the year. So I wanted to have a template where I can quickly start a new Love 2D project, and everything I need is baked in and I can just start coding and publishing. So what I've created is a sort of a project bootstrapper for Love 2D games. And it's a VS Code or Codium template organized in a workspace. It will automatically install all of the extensions that you need for Lua and Love and debugging and shader language, syntax highlighting, and a whole bunch of stuff like that. But the thing that it really does, which is the hard bit, is it's a whole load of GitHub actions baked in. And this is where me talking about Act in the last episode came from, because what I was doing was using Act in order to iterate on these very large GitHub workflows for building games for, and the ones that were tricky, like Android, iOS, macOS, Windows to some extent. I mean, what's kind of amusing is I'm actually building the Windows version of the game in Linux containers because Wine is amazing now. So you can actually build the game using a Linux container, which makes me very happy.
It's funny because for those who don't know, when you ship a Love 2D game, I mean, we call it Love 2D, but I think generally it's just called Love now.
I think it is now, yeah.
If you call it Love, then people wonder what on earth you're talking about. So we generally call it Love 2D, so you know what we're saying. When you ship it, you're shipping basically the source code of the .lua files and the Lua executable. So you can just give someone a zip file renamed to .love, which contains all the files, all the .lua files, and just drag and drop it into the Love binary or run Love and then your game or the current folder, and it will just find it and it will do the right thing and launch the game. But some people don't like that and they want stuff packaged up and in stores and stuff. And I think that's the primary goal, isn't it?
Yeah, and part of this is sort of to make things like releasable artifacts. So there's a mechanism called fusing in Love where you can use the Love binary and fuse the Love bundle to it to make a new sort of executable in air quotes. So I've done that for all of the platforms to make it more like an actual deployable artifact.
So that then just gives you a big executable to distribute then, does it?
Sort of. It gives you an executable and the shared libraries that are required to run it on a given platform.
Right, got it.
Because
yes.
Love itself uses things like SDL and OpenGL and what have you. So at the moment, it builds for Linux. It makes an app image and a tarball for Linux. The tarball because I want to target Steam, and so you can use the tarball for that. And it makes a macOS DMG image, and iOS, it compiles the iOS stuff, it compiles the Android stuff and so on. But what I haven't done yet, because I haven't paid for my Apple developer license, I won't do that until I've actually got something that's close to being publishable, is it doesn't do any of the code signing or notarization. Yeah. But I will add those steps when I've actually got an account and, developer keys and all the rest of it.
So I tested this and surprised Martin because his template has a game in it. It's not a real game. It's just like you just move your mouse around and the cursor moves around, and not much more than that. It displays the frames per second. So I surprised Martin by building it on my machine and then sending it to my Steam Deck and trying it on my Steam Deck, which I could just touch the screen and it pretends like it's a mouse button, and it works. It just worked. I didn't have to do anything extra to make it work on the Steam Deck. It was really cool.
Nice.
My template game is X-Eyes, basically, if you've ever seen that.
It watches your cursor.
Yeah, it watches your cursor and it screams if you touch its eyeball. And the screen shakes, little bit of glitz and glamour.
But you've worked on this for a little bit now, haven't you? And I'm impressed. Without even having a game, an actual game, all of this framework makes it super easy. You can just how do you get started if you wanted to use this? What would you do?
It's a GitHub template. So you effectively say, start a new project and use this repository as a template, and it just deposits everything in there. And then you just replace the default game with your own code and you're off to the races. The other thing I recently added is it's got a full debugger and profiler, because I'm learning this as I go. And I made some mistakes I learned quite quickly in my rendering pipeline. So on the Steam Deck, through hard button combinations and on the keyboard on your computer, you can turn on the debugger and get a full trace of the rendering engine. And so you can see what the frame time is and the frame rate and where all of the objects are and stuff like that.
And is this you embedding tools that are part of LÖVE 2D, or is this stuff that you've created?
The debugger and profiler is basically just an overlay that talks to the LÖVE API to get the statistics that the LÖVE API tracks in the rendering engine. So it's nothing particularly clever, but it is quite helpful, because the other thing you can do is you can turn VSync on or off using the debugger. Mm-hmm. And this is super important when you're working on a game, because you always need to make sure you've taken account of delta time when you're actually doing all of your movement and, physics calculations, because otherwise they go at the wrong speed and things go a bit weird. So I can quickly toggle VSync to make sure that everything's actually running to time.
It was funny. I only ever seen VSync give you 60 FPS because all my monitors are 60 FPS. And then I ran the action to build a Mac version on my work Mac and launched it. And it launched on the internal panel. And because it's a MacBook Pro, it's got one of those special screens that does 120 FPS. And I saw 120 in the corner. I thought, wait, what? How? And it's just because the panel is 120 FPS. And because he'd got VSync on, it locks to the frame rate of the internal panel. As soon as I move the window to another display, it drops down to 60. But yeah, it worked really well. I was really impressed with that.
Yeah, my computer in the office has got 3 screens attached. One that runs at 60 hertz, one that runs at 100 hertz, and one that runs at 120 hertz. And it's kind of fun dragging the game window between the 3 monitors and watching the frame rate change. And it's another good delta time test, because as you drag the game between the 3 screens, you shouldn't see it speed up or slow down as it moves between, the different frequency screens. So next on the list is adding the ability to publish to Steam, so that you can, automate your Steam publishing pipeline. So once you're, in the throes of getting ready to release, you can do this. And I think next month, so as we record this, it's February. So I think in March, it's going to be the LÖVE Game Jam. So I'm going to share this template with the LÖVE community ahead of the Game Jam, so that everyone can start with something that will build and publish their game to itch. And there'll be no 11th hour drama with people having to worry about how to build and distribute their game.
There will be 11th hour drama. It just won't be packaging. There will be the 11th hour drama. Yes.
this wasn't a nefarious plan to give yourself a massive head start over everyone else then.
No, it is that as well. So when I did this with Pico 8, when I did the game jam with Pico 8, I didn't start writing the game until the day of the jam. But what I did do was write an equivalent of what I've just described, but for Pico 8, because I knew I didn't want the headache of maybe spending half a day messing around with that stuff when you're really probably trying to iron out the last niggles in the game. But it means now it's cheap to start a new love project, and you can just start love projects for fun and test out stuff. So the way I'm iterating on the game I'm actually writing is making really small prototypes of individual mechanics as individual projects to test an idea out, and I can keep that as an isolated thing and then in air quotes throw it away or keep it for reference, so then I can think about how to properly integrate that idea into the game proper.